All right, what we're going to do here is we're going to do a couple of examples where we apply the properties of logarithms, okay? And in both of these situations, the one you see here, and then we'll do another one in several minutes, we're given some initial information. So here we're told that u, letter u, is the same thing as log of 3. And w is the same thing as log of 4. And what we want to do is we want to try to identify what each one of these things is in terms of u and w, okay? And so what we have to do is we're given the logarithm of sort of unusual, some of them are unusual numbers, right? And what we need to do is we want to try and find out how these numbers are related to 3 and 4. So it takes a little bit of creativity, okay? I can tell you that 0.75 is the same thing as 3 divided by 4. 3 divided by 4 is 0.75, right? So we could rewrite this one as the log of 3 divided by 4, okay? And so now that's going to be the same thing as, since we have division here, we can do log of 3 minus log of 4. So this will be the same thing as log of 3 minus log of 4. And log of 3 is u. So we'll write u minus, and log of 4 is w. So we'll put a w. And so log of 0.75 is the same thing as u minus w. Okay. 36. How is 36 related to 3 and 4? Sometimes what you might want to do is divide a number or multiply a number by 3 and 4. Okay. Well, if we divide 36 by 4, so 36 divided by 4 is equal to 9, and 9 is equal to 3 squared. So we could break this up into 4 times 3 squared, because 4 times 9 is 36. So 36 is the same thing as 4 times 3 squared, okay? So if we do that, let me erase this, make some space. Then we can break it up into u and w. So we're going to say that this is the same thing as log of 3 squared times 4, because 3 squared is 9, and 9 times 4 is 36, okay? And now we'll break this up, because it's multiplication, we can break it up into 2 logarithms, 1 logarithm for 3, 1 logarithm for 4, but this is multiplication inside. We're going to make it addition between 2 logarithms. So we'll do log of 3 squared plus log of 4, okay? And then this 3 squared, we can take this 2 and move it to the front of the logarithm, right? And so this will become 2 log of 3 plus log of 4, and log of 3, that's u, and log of 4, that's w, so we'll have 2u, okay, so 2 times u plus w, okay? So 2u plus w, okay? Now this one, log of 1.6875. Now this is a little crazy. So what I'll usually do is I'm going to go to a calculator and I'm going to multiply this number by 3, and I'm going to multiply it also by 4, and I'm going to try to find something that looks familiar, okay? So let's go to a calculator, and I'm going to do, let's see, what did we have there? We had 1.6875. 1.6875. And I'm going to multiply it by, I don't know, let's multiply it by 4 and see what we get. Oh, 6.75. Now let's multiply 6.75 times 4, and we get 27, and 27 is related to 3. 27 is 3 cubed, okay? So basically what we have here is we have 3 to the third power divided, whoops, I messed that up. Now let's go back here. Let's do this. How about 3 divided by 4? Okay, you may not have understood what I just did. but let me show it to you now. 3 to the third power over 4 squared, okay? And this is 27 and this is 16. And so it should be 27 divided by 16. And sure enough, 1.6875 is 27 divided by 16. So we're going to do 3 to the third power over 4 to the second power, okay? So this is the same thing as, so log of, it's the same thing as 3 to the third power over 4 to the second power, okay? And so now we're going to break this up into two logarithms because we have division, so it's going to become subtraction. This is going to be the same thing as log of 3 to the third power minus log of 4 squared, okay? Now we're going to move the 3 on the exponent into the front of the logarithm, and we're going to move the 2 exponent into the front of this logarithm. So we're going to have 3 log of 3 minus 2 log of 4, okay? And so now log of 3 is u, log of 4 is w, and so we'll have 3u minus 2w, okay? 3u minus 2w, okay? All right, we got 2 more to go now. This 15,552 is a little intimidating, but I'll bet if we divide by 4, we might, or 3, we might get somewhere. So 15,552, we're going to divide that by 4, and we get 3888. Let's divide that by 4. And so that's going to be 972. Let's divide it by 4 again. 243. 243 is 3 to the 5th power. So remember that? So we just divided by 4 3 times. So that's 4 to the 3rd power. That means multiply by 4 to the 3rd power. And 243 is 3 to the 5th power. Just a reminder, let's do 3 to the 5th power. And I'll remind you, and sure enough, 243. So 3 to the 5th power times 4 to the 3rd power. Whoops, hang on, let's go back here. To the 5th power times 4 to the 3rd power gives us, 15,552. So 15,552 is the same thing as 3 to the 5th power times 4 to the 3rd power, okay? So this is log of 3 to the 5th power times 4 to the 3rd power. And so the multiplication will become addition. So this will become log of 3 to the 5th power plus log of 4 to the 3rd power. And now we can move the exponent into the front of the logarithm. So the 5 will go to the front of this one, and the 3 here will go to the front of this one. And we'll have 5 log of 3 plus 3 log of 4. And now this log of 3 is u, log of 4 is w, so we have 5u plus 3w. So 5u plus 3w. There we go. All right, I had to change this one because the previous example I had there, it wasn't working out correctly. So let's do, now the last one we're going to do is log of the square root of 5184. So let's look at this 5184 and see if it's related to the numbers 3 and 4. So we'll take 5184 and we will divide it by 4. And sure enough, divide it by 4 again. Good. Divide it by 4 again, and we get 81. And we know that 81 is equal to 3 to the 4th power. So we did 3 4s, 1, 2, 3. That means 4 times 4 times 4 times 3 to the 4th power, which is 81. So that's 4 to the 3rd power times 3 to the 4th power is 5184. So we got it. Okay, so let's go back here. And this is going to be log of the square root of 3 to the 4th power times 4 to the 3rd power. Okay, what we're going to do is this square root, we're going to make it the 1/2 power. So we're going to write log of, in new additional parentheses, 3 to the 4th power times 4 to the 3rd power, okay, to the 1/2 power, because 1/2 power means square root, okay? And so now what we're going to do is we're going to distribute the 1/2 power to the 3 and to the 4, okay? And so 3 to the 4th power to the 1/2 power becomes 3 squared. So this will become log of 3 squared times, and then 1/2 times 3 is 3 over 2, and we have to leave it just as 3 over 2. So this will be 4 to the power of 3 over 2, okay? Now this multiplication is going to become addition in between two separate logarithms. We're going to have log of 3 over 2 plus log of 4 to the 3 over 2. Okay, so equals log of 3 over 2 plus log of 4 to the power of 3 over 2. And now what we can do is we can take this exponent of 2 and move it to the front. We can take this exponent of 3 over 2 and move it to the front. And we will have 2 log of 3 plus 3 over 2 log of 4. And log of 3 is u, log of 4 is w, so we have 2u plus 3 over 2w, okay? And that's it for these. It's a little crazy, but we're able to apply properties of logs. And now we're going to try another example. All right, so this says, suppose c is equal to the natural log of m, and d is equal to the natural log of r. And we're going to do something similar like we did in the last one using properties of logarithms. Okay, only now we don't have numbers in here, we have letters. So the natural log of r times m. Well, this is multiplication in between r and m, so we can turn it into addition between logs. We can do the natural log of r plus the natural log of m. And the natural log of r is d, and the natural log of m is c, and so we can just say d plus c. We could also say it is c plus d because addition is commutative, okay? But this one, we can't switch it around. Natural log of m divided by r inside means subtraction in between. So we can do the natural log of m minus the natural log of r. Natural log of m is c minus natural log of r is d, so we just have c minus d. Now we have the natural log of the cube root of m times the square root of r. Well, let's turn that into fractional exponents. This is now going to become the natural log of m to the 1/3 power times r to the 1/2 power. Okay. And now this multiplication is going to become addition. Natural log of m to the 1/3 power plus the natural log of r to the 1/2 power. We can move these exponents to the front, and this will become 1/3 the natural log of m plus 1/2 the natural log of r, which natural log of m is c, natural log of r is d, so this is 1/3 c plus 1/2 d. Okay. Now this one, natural log of m times the natural log of r. Now this looks tricky, and you may want to turn this into addition, but you can't. This does not become addition. This multiplication is not happening inside of a logarithm. It's happening between logarithms. But I have good news for you. Natural log of m is c. So I can just write c times natural log of r, well, that's just d. So this is just c times d. That didn't even need any properties of logarithms. Same thing for number 5. Natural log of m divided by natural log of r. This division is not happening inside of a logarithm. It's happening between two logarithms, and so there is no property for this. But natural log of m is c. So that's the numerator, c, divided by natural log of r is d, so it's just c over d. Now to find m times r, there's no logarithm here, and so it's going to be difficult. We can't use properties of logarithms, but I can tell you this. that since c is equal to the natural log of m, I can rearrange this. I can do e to the power of c equals m. I can convert this into an exponential. This is the same thing as e to the c power is equal to m. So m is equal to e to the c power, okay? So this m is e to the c power. So I'm just going to put e to the power of c. And I can do the same thing with d up here, right? I can do e to the power of d equals r. And so r is the same thing as e to the d power, okay? And this is a little messy in here, so let me rewrite it out here. So this is e to the c power times d to the, or sorry, times e to the d power. Now this can actually be simplified. Since we have a common base, we can and multiplication in between the exponents, we can add the exponents together. So this will actually become e to the power of c plus d. This is correct and this is correct. Okay, we're going to do something very similar here. Do you see this addition inside of the logarithm? That there's no property for addition inside. The property is for multiplication inside. It's for addition between logarithms and multiplication inside. There is no property for this. So, but we do know, we already learned over here that m is equal to e to the c power and that r is equal to e to the d power. So we can write this as the natural log of e to the c power plus e to the d power. And there's no way to simplify this, okay? And that's it. I hope, yeah, I recommend maybe watching this video a couple times on some of the harder ones, but I hope this helps you better understand how to apply the properties of logarithms.